Hey everybody, Bill Sky the computer guy here, and in this video what we're going to do is that we're going to start talking about conditional processing in either your C or C++ program, maybe your Java program, maybe your Python program, or maybe your assembler language program. But what we're going to do before that is that we're going to talk about a thing called flowcharting. Oh my god, people's eyes are rolling. And the reason for that is because flowcharting is a way to graphically document your logic and your code. And there has never been a single company that I have ever gone to work for that didn't require me to do some sort of design and then documentation of that design using flowcharting or hierarchy charts. So, and there's so many other ones. There's there's object diagrams, there's data definition diagrams, there's ER diagrams. I mean, diagrams are so popular, and you can find that out by just looking at all the tutorials out there. I mean, this isn't the first time somebody's done a flowcharting tutorial, but it's something that everybody needs to know, and you may actually be asked to do this on a job interview. They want to see what your breadth of your education is. They want to see what the breadth is of your experience. So don't roll your eyes at this. Let's just do it. And then we're going to go on to conditional processing in your chosen language. I'm putting this video in front of every one of those. You can skip it if you want, but you're going to be doing yourself a big disadvantage by doing so. So let's get going with this demo. Now, what I've got here is I've got Linux running in a VMware guest operating system, and I have this thing called draw.io installed. Now, draw.io is actually an internet tool, but there is a desktop version that you can download. You must have an internet connection to make it work, which is a little bit disadvantageous. And there are other tools out there. I mean, there are companies that charge a lot of money. Some of them are Visio, OmniGraffle. There's just eDrawMax. There's a lot of different tools out there, and the reason that they're out there is because this is a necessary skill and it's a necessary document that you have to produce from now and again. So what we're going to do here is we're going to use draw.io. Now, how can you get draw.io? Well, I'm going to go to the internet and I did a search for draw.io, and there it is, drawio.com. I'm going to click on download. And from there I can download the Windows installer, the portable version. It's not an installer, you just put it in a folder. Mac OS, we've got different versions of Linux. We've got for Red Hat, we've got for Ubuntu and Mint, we've got Snap and App Images, and also there's a plugin for Chrome OS. So you can download any one of those. I actually downloaded the Linux version, and so let's create a diagram and let's talk about how conditional processing is diagrammed in flowchart. So I'm going to click on New Diagram, and I'm going to click on Flowchart and just say Create, and there's my first flowchart. Now I'm going to expand this. So what is a flowchart all about? A flowchart, and before we actually get into that, notice over here on the left you've got the different symbols. Flowchart is what you want. You don't want general, you don't want miscellaneous, you don't want advanced. You want the flowchart symbols. And so don't get those confused because each symbol means something different. So I'm actually going to select everything. And the way that I'm doing this is I'm holding down my mouse button and dragging, and it selects all the symbols, and I'm just going to delete those with the delete key. Now, what is a flowchart all about? It's like a map. It's like a map you might find when you're driving from here to Albertsons to go get something, and you're in a city you don't know, so you set up, where do I go? And it tells you, well, you go here, you go there, okay? And it really shows you the organization of your thinking, your logic, whether or not you're doing the right thing, what you should do if this happens, if that's an interesting term. So all flowcharts start with this idea of a starting symbol, and the starting symbol is basically just an oval, and you just say start. Some people put begin, but it says this is where the program starts now, or the algorithm starts. Now, every programming language has an entry point, and that's the same with flowcharting. You've got to say, where do I start in the program? The operating system requires it. Programs require them to be linked that way if it's going to be an executable program. So that's what we do in a flowchart. So what are some of the other symbols here? We've got this square symbol called the process symbol, and I'm going to drag this out here. And a process symbol is used to do things like initialize variables, do mathematical equations, things like that. Now the way that this tool works is that if I move my mouse over the start button, it might be a little difficult to see, but there are these little arrows that pop up on either side of the symbol. And I'm just going to grab, with my mouse button, I'm going to grab that, I'm going to connect it, and notice how the process symbol now is highlighted. Now those are connected. So if I move this around, it's automatically connected. Now this is pretty cool for a free tool. Draw.io is actually pretty good. Now I'm going to go up here in File and Save, and I'm just going to call this Intro to If Statements. And so what do you put inside of a process? Well, I'm going to just say set X, Y, and Z to 0. Now some people might say, well, shouldn't I just go ahead and put the program code in there? Well, a lot of times flowcharts are done before you even know what language it is that you're going to use to write your code. Your project leader may not know. Are we going to do this in Java, C, C++, Rust? Are we going to do it in Python? They just don't know yet. So a flowchart is supposed to be language autonomous. It's not supposed to be for a specific language. You can do it for a specific language, and I've seen it done that way, but an initial flowchart is normally not based on a language. So I'm going to make that process a little bit smaller. So we have another symbol here, and this is what we call the display symbol. And all you do is you move your mouse over the symbol, and you can see the symbol name. The display symbol is what do you display on the screen. So I'm just going to say I'm just going to display some type of a message, web welcome message, and then I'm going to connect my process box to my welcome message. So what this is saying is that we start here, we set up the variables. Now those variable names are horrible, but I'm doing it just for effect. And then after that we go to the welcome message. So that displays it to the screen. So let's say we want the user to input something. Well, there's this thing called manual input. That symbol, it kind of looks like a square with an angled top to it. The manual input, and I'm going to connect it immediately. The manual input is normally a lot for like keyboard input. So I'm going to input username. Now there's a problem with this flowchart already, is that we have a welcome message, but we're not actually, and we're asking the user to enter their username, but we actually haven't said please enter your username. So I'm going to go ahead and delete that connection, and the way I did that was I just clicked on the line and pressed the delete key. And I'm going to drag another display symbol out onto the flowchart. And we're going to say please enter your name. Now the fact that these symbols mean display, you don't have to say in the symbol display please enter your name. It simply means, the symbol itself means to display it on the screen. So that's one of the benefits of using these symbols. The actual text inside of them is less. And so now we've got username. So that's manual input. That symbol means manual input. So you're going to somehow input that into a variable, and we call that variable username. Now let's talk about decisions. So what if the user just presses enter and they didn't actually put in a username? Well, we've got this other symbol called a decision symbol. And what I'm going to do in there, I'm going to say is the length of the username equal to 0. Now if you notice our text is getting kind of scrumbled here, so we're going to make it a little bit bigger, and then we're going to go in here and I'm going to put an enter key there, enter key there. So that's one of the things that I'm not too super excited about with Draw.io. Its text management isn't as good as some other ones that I've seen. So let's go ahead and grab that. Now the decision symbol is the only symbol where you can have multiple paths coming out. If you notice, all these other symbols have a single path. They have a single line coming out. Because you need to know, where am I supposed to go next? That's the whole point of an algorithm. That's the whole point of a program, is the direction of flow control. But the decision symbol is really the only one that has multiple paths that come out. And that's based on the answer to the question. So in this case, it says, is the length of the username equal to 0? Well, I'm going to say, in the first answer is yes. So if it's yes, I'm going to display your name cannot be blank. Please try again. And again, we don't have to say display because we already know that the symbol means display. And then I'm going to take a little line and connect it to that. And then I'm going to double click on the line. And I'm going to say yes. So that is the yes condition. Now, once we display that the name cannot be blank, what do we want to do? Well, I think we should go back up to please enter your name. Now, if you notice the way that draw.o drew these things, they're a little bit, they're a little bit overlaying. So I'm going to just grab this and put it over there. So there you go. So that's our first decision. And that's really what computers are all about, is asking questions. Even artificial intelligence, or the overused term for artificial intelligence, in my opinion, well, fact, is that it's just a very good, well-written, statistical-based algorithm. And it's all based on ifs. Everything is based on questions. You ask questions. So that's the yes condition. Now, what is the no condition? What is if it isn't equal to 0? Well, you could display something to the user. So yeah, I could come here and I could just say, welcome username. So I could just have that display, welcome username. And I can make those larger, I can make them smaller, whatever I want to do. And we need to put, when is that going to go in that path? That's going to go on that path when the answer to our question is no. So welcome username. Now, the next thing you might want to do is, let's say this is a little program that's going to calculate Pythagorean's theorem. So what I'm going to do is, instead of x, y, and z, I'm going to set a, b, and c to 0. So those are our variables. And what I'm going to do now is I'm going to ask the user to enter those. So I'm going to say, please enter the A side of the triangle. And we want to make this a little bit bigger. And then we're going to have a manual input. So instead of dragging it from over here, I'm going to select it, press Control C to copy it, and then Control V to paste it. Now, one thing I want you to notice is we're getting close to the end of our page. That means, now this page is 8.5 by 11. It's assuming you're going to want to print it on a piece of paper, and that is very common to do that. But because we're basically doing an architectural diagram of our logic, I want to make this page a lot bigger. So what I'm going to do is I'm going to go up to File, and I'm going to say Page Setup. And instead of, oh, it's A4, so it's more like business, I'm going to go down to Custom, and I'm going to change this to 40 inches by 40 inches. So it's going to be a really big work area. So you can see our page is a lot bigger now. Okay, so there's username. So we're going to have them input the username, and we're going to connect that. Now we're going to want to ask a question. And now, oh, it's not username, it's A. So we're going to have them enter A. So now we need to ask another question, and the question is going to be, and you can probably come up with this, did they enter 0? Or did they enter a negative number? Is A 0 or negative? All right. If it's not, we're going to ask them to enter, oops, what did I just do? We're going to have them enter B. Now I want to make sure that I put is A 0 or negative. I'm going to say nope. And now we're going to have them enter B. I'm going to ask the same thing. Again, I'm just copying and pasting these. It's just a little bit easier. Is B 0 or negative? Now, after they enter in B, we can calculate C. So I'm going to use the process box underneath that. Calculate C squared equals A squared plus B squared. So there's our calculation. Now we have to make sure we fill this in. Nope. All right. So what can we do here for these two decisions that we haven't actually put any kind of action to? Well, I'm going to make this simple. Instead of having a separate output for each one, I'm going to say all triangle sides must be non-negative and greater than 0. So I'm going to put that exact same message there. And if it's negative or 0, I'm going to go to this box. If it's negative or 0, I'm going to go to this box. Now this didn't really connect, so let's get that connected there. Let's put it there. Okay. And I'm going to say yes, yes. And then once we go from there, I now need to take it back. Now I need to take this somewhere. Well, I'm going to have them put it in there, and I'm going to redraw this a little bit. Okay, just like that. Now let me zoom out of this a little bit. Okay, so we asked to enter in A. They actually enter A. Is A 0 or negative? Yes, it's going to go here. It's going to have them enter A again. Okay, that's cool. If they didn't enter 0 or negative for A, it's going to go to that. Please enter B. Is B 0 or negative? Yes, it goes to there. But guess what? It's making them go all the way back up and re-enter A again when A was already valid. So maybe that's not a good design. And that's the kind of thing that you would show in a design review when you go into a meeting and everybody looks at your design. They're like, why are you making them type in A again? Well, because I was too lazy to put it in the flowchart. Wrong answer. So what we're going to do is I'm going to delete that one. I'm going to move this up here. And I can display the same thing, but I'm going to make it a little bit more specific. The value for A must be greater than 0. Okay? And then we can do the same thing. Oops, I keep pressing the wrong key entry. So, there we go. Or I should say keyboard combination. All right, so now this one should be B. Oh, we forgot something. We forgot the manual input for A. Oops. So we need to make some changes here. So I'm going to drag this down. And this is the beauty of doing this on a tool like this, because you don't have to do a lot of copying and erasing. So we forgot our manual input. I love making mistakes. Let's connect those. Let's connect that. Okay, is B negative or 0? Yes. So we're going to display this error message, and then we're going to take us back up to please enter it again. And we have to make sure that we label all of these. So is B 0 or negative? Yes. All right. So there you go. So we've got decision making here. We've got what we call branches or jumps to other code. Take a look at the if statement for C and C++, Java, Python videos that I'm producing, or in assembly language. Take a look at all those. It shows you how you would actually implement these. And I'm going to double check this to make sure it looks right. There's A, there's B. Okay, well, we don't have an end of the flowchart. Where does the algorithm end? Well, we need to do something. Once we calculate the value, we need to do something. So I'm going to display C, well, let's say the length of the hypotenuse is C. Now, the calculation doesn't quite look right. I didn't really put in the exact calculation. So I probably need to say something like hypotenuse equals the square root of a squared plus b squared. And then I'm going to print, not C, but I'm going to print the hypotenuse. So I just discovered that I need another variable, and this is all before I write code. So I need another variable. So I need a variable called hype. So I'm going to come up here and I'm going to say AB set hype A, B, and C to 0. And there's my equation right there. I'm going to then display it, and then I'm going to end the program or end the algorithm. And there is, now I can use the start again, but this draw.io actually has a terminate symbol. And I'm going to drag it. And I'm going to say end. So then the program ends. Now this is kind of a lame program. Well, not really. I mean, we've got a number of if statements in here, another number of decisions. But you may, instead of just ending the program, you may want to take this and go back up here and have them enter in the have them enter in A, B again. And again, I'm not crazy about the way that draw.io does this. The problem is that now we have what we call an infinite loop. Is that this is always going to go up to here. So how is the program ever going to end? Well, you might want to do something like, let me delete this. You might want to say something like, would you like to do this again? And I'm going to put that down here, and you're going to see why in just a moment. Let's get rid of this line. Okay, would you like to do this again? Now my code's going to kind of go up. And actually, that's probably not, well, let's see. How do we want to do this? So I'll put it there. And I'll say, oh, we haven't actually input anything yet. So let's do this. Let's say we're going to put the answer into a variable called answer. And then I'm going to ask the question, is answer yes? If it's yes, then I'm going to go all, now I haven't put in my lines yet. Let's get those lines in there. Okay. If the answer is not yes, I'm going to end the program. So I'm going to say no. The answer is not yes. If the answer is yes, I want to go all the way up to the top here and have them enter A again. And let's get those lines right. All right, there we go. And we want to double click on that. And let's zoom out. So now we have a flowchart that describes how the program is going to work. It has a loop in it, which is this one right here. The decision boxes are the only ones that have multiple lines coming out of them. I mean, let me give you an example of something a student of mine did once. And I'll zoom in here. So what is the problem with the length of the hypotenuse's height? So if we look at that, and we have two lines coming out of it, which way do we go? It's like your GPS showing that you're at an intersection and you go straight and you turn right at the same time. Which way do you go? You can't guess it. I mean, you could, but maybe you won't get to your destination. It's the same here. You can't have two lines coming out of a box unless it's based on some type of a condition, and that's why the diamond, the decision box, is really the only one that can have multiple lines coming out of it, because you got different conditions. You got different values or reasons why you might leave it in multiple. So this is not good. So the only, and we actually, it looks like I don't have some of these connected just right. Okay, there we go. So the only box, it still isn't connected. There we go. So again, the only box is the decision box that can have multiple lines coming out of it. Now I can take this flowchart, I can take it anywhere and to any language, and I can implement it. Okay, it is a global flowchart. It doesn't specify any kind of a language. A little bit C++ or Java because of SQRT and the double asterisk. I could have expanded that a little bit more, but I mean, I think every programmer knows that. Maybe I'm making an assumption. But anyway, so that's what a flowchart's all about. It's to diagram what it is that you're going to do. Now, if you noticed, I made a few errors here, and you as a beginner may make those same errors, but not realize that you've done it. So when you take this design to a design team, and if you go work for a large company or even a medium-sized company that's worried about quality, they'll have your design reviewed. They'll see these errors. They'll say, nope, you got to fix this. And the beauty of it is that you can do it on a tool like this instead of paper and pencil. Now, what do I mean about paper and pencil? Well, back when I was learning, we had a thing, and I don't know how this is going to show in the, and maybe I should find a diagram of it. So let me actually find a picture of it. We used a thing called a flowcharting template. So I'm going to say flowchart template picture. And let me show you what it actually looked like. And a flowcharting template, now you got all these sponsored. By the way, Lucid Art chart, you may want to stay away from that because they require money. You don't need any of that for this type of thing. So I'm going to go over here to images. And I don't even know if they're going to have one. So let me do this. Let me type IBM flowchart template. Oh, we might have to look on Amazon. Here we go. So this is what we actually, and I still have my original one. I wish I had it with me to show it to you right now. But, and I don't know what's going to happen clicking on that image. There it goes. This is what we used to use, and you can actually still buy these online. I don't think you can buy the IBM one, but you can still buy these on Amazon or other online shopping. And every symbol is depicted here that we went through. You can see the decision, you can see the process, you can see the manual input, you can see the display. They're all there. And why did we have that? Because we didn't have graphical user interfaces back in the day. We didn't have flowcharting tools back in the day. The first flowcharting tool I ever used was a thing called Bachman, and that was more of a database design tool, and that cost my company over $100,000 because it was graphical, but it was at the very beginning of graphical user interfaces. So I actually used to give these to students as a gift at the beginning of the semester, and I'm not sure why. And you can go on Amazon, you can say flowchart template, and you can buy them. And the reason you can buy them is that they're still popular, they're still used, they're not very expensive. And if you don't want to have to use a automated tool, then you can buy one of these for $10 and you're all set. Okay, so that's flowcharting. Now let's move on to some decision coding in the language of your choice.